further ado to Shankar.
And guys, one last thing, we're also going to be recording this session, so I've just hit the record button now.
Sure.
Cool. Over to you, Shankar.
Sounds great. Thanks, Arushi. Thanks, Rajiv, for the context and setup. Am I audible and clear?
Yep, it's good.
Okay, great. Okay, I'll start with a simple quote that you see in front of you. This is actually a very interesting take on what artificial intelligence is. So Larry Tesler is for those that don't know, is a guy credited with coming up with cut, copy, paste functionality. So without him, we wouldn't have probably the most used functionality in, if anybody has used computers at all. So he basically said, look, let me not define artificial intelligence. Let me actually define what intelligence is. And he said, whatever machines haven't done yet should be classed as intelligence, which means that the whole idea behind this definition is that you cannot define it. It is a moving definition, and with everything that we learn every day, the definition of what intelligence is expanding and evolving. So I'll start with a very heartwarming story. When we think about AI, most people think about robots and sci-fi movies and so on and so forth. But actually, the most fundamental example around the use of AI comes from cucumber farming. So this is this gentleman, this young gentleman there is Makoto Koike. He's essentially an engineer. And he was a systems engineer working, for a company. And his parents were cucumber farmers, And the interesting thing about cucumber is that there are about 9 or 10 different varieties of cucumber, which need to be sorted with lots of precision. And the reason behind that is that each of these cucumber types have different price points, and getting them wrong could mean significant impact on the P&L as we understand it. The other interesting thing about cucumber sorting is also that it is a very painful manual task. He had observed his mother and father spending 8 to 12 hours every day over a period of 2 to 3 weeks looking to sort cucumbers to get them ready from harvest to the market. And by the time they would finish sorting, they would actually lose a bunch of the produce because it's gone waste. So he saw a clear opportunity here to understand how to help his mother and father sort cucumbers better. But he's not he's from a very normal part of the Japanese society. He wasn't he didn't have access to the best and most sophisticated computers and engines and so on. What he did was he bought himself a $35 Raspberry Pi computer. It's the world's cheapest computer. He bought himself one. He downloaded this software called TensorFlow, which is a free AI software from Google. He bought that. He purchased a Raspberry Pi computer, and he then went about the task of actually figuring out what happens. So essentially, what was happening is he had to do exactly what his mother was doing, but through a machine. So he took a lot of pictures of the cucumbers and the different types of cucumbers as his mother was sorting them. And as she was placing them in different sort of cohorts, he was capturing a lot of pictures using a normal camera. And he then created a simple application which would identify these cucumbers and then push them into the right bucket. So that's all. It was a simple process of looking at all the cucumber images, placing them in the right containers, and very quickly his accuracy levels on cucumber sorting went up to 90%, right? And this is one of the most fundamentally interesting examples of how AI can be all pervasive and be applicable to pretty much everything that we do. But what is happening? What is the AI here? What is actually happening? So let's understand that a little bit. So if I look at the cucumber farming process, there's about 4 steps which are done in an iterative manner. The first thing is categorization. Cucumbers are getting categorized into, actually the first is seeing the cucumber. He put a camera to view the cucumbers from multiple angles. So he had a bunch of images. which were then categorized into the 9 types that his mother was manually doing. Once those 9 types are there, they were then sorted into various bins. So this is actually, some execution that's happening where all these cucumbers are being sorted. Now, each of those were then, each of those categories were then identified as the best to the worst, which helps them price the cucumber. And of course, it won't be 100% right when it is done in an automated manner. So there is an iterative loop where the mistakes that happened in some cucumbers being sorted wrongly were categorized further, and this whole loop continues. So this is all that's happening. There's 4 steps that are happening. There's seeing the cucumbers, categorizing them, sorting them, and understanding those categories. Now, why is this interesting? That's what AI is. So AI essentially, if you just distill what happens in this cucumber farming process, is the first step is about understanding, perceiving what is in front of you, right? Lots of images. So collecting a bunch of data to convert something that is that his mother and father did into a digital data point. That is the first step. The second step is what is called as knowledge representation, which is converting these images or digital data points that you have into something which allowed him to process these data points. Then the third step is what is called as the action, right? So the action could be a decision in terms of categorization. It could be about figuring out what's the right price point. It could be about identifying how these need to be placed into different buckets and so on. And the fourth step is learning, which is how do I do it better every time I do it. So that's really what's happening. It's this 4-step process of perception, processing, acting, and learning. And that really is, at least in our world, a good comprehensive definition of AI is the ability of a system, which is a non-human system, to match or exceed human capability to perceive, process, act, and learn. Right? Now let's move forward and just think about what happened in the past. This is, with lots of good knowledge that we have right now, we've come up with this definition. But the origins of AI was somewhere in the early 1950s, and the idea of computer-based intelligence was, one of the first things that happened was when Alan Turing proposed what is now come to be called as the Turing test, right? Which is, can a computer communicate well enough to persuade a human that it too is human? So can a computer fool a human? So that was the fundamental question that he answered. And that's how the first ever version of artificial intelligence happened. But a few months later, a bunch of students from Princeton built the first artificial intelligence system, using a few vacuum tubes and a gyro pilot, which was basically a surplus from the World War II. And the term artificial intelligence was coined in 1955 by John McCarthy, which is what you saw earlier. Now, the same year, what also happened is the researchers at Carnegie Institute of Technology, they produced the first ever AI program, which is called the Logic Theorist. But that was, great excitement. The early 1950s was a series of great excitement around this new innovation. But very quickly, the advances that happened during 50s were around, the Stanford AI lab was formed, the MIT AI lab was formed, and so on and so forth. But very quickly, the excitement around AI died in the late 60s and early 70s. And this period is called the first AI winter. And the reason it's called the AI winter is because funding slumped. They realized that artificial intelligence was interesting, but they didn't have any practical use cases or applications that they could work on or the governments could fund. And for the next about 10 years, the environment was quite bleak, and there was nothing happening. Then the next stage happened, stage 2, which is the stage of machine learning, where companies like Microsoft came into existence, and they started developing what is called as expert systems. So expert systems are essentially software programs that assess a series of facts or a set of data using a database of knowledge, and then present solutions to various problems, right? So this is when the first ever computer controlled autonomous vehicles came into existence. These are essentially industrial robots that came into existence. You know, the pictures I'm sure we've all seen in movies. They started to appear, and but again, they couldn't come up with more practical applications because of various reasons. It was expensive. We didn't have the amount of data that was needed for AI to be accurate. And eventually it became the interest area for a few researchers and nothing more. So there was another AI winter period in the 90s, if you will, when the world started looking at Y2K and things like that. Then the stage 3 happened, which in my view at least is a very serious inflection point for the world. Because in the 2010s, this whole concept of deep learning came into existence, and deep learning essentially created exponential level of interest in the field of artificial intelligence and machine learning. And what happened was this bunch of advances, and Arushi pointed out a term earlier to me. There were combinatorial advances that happened. Advances not just in sophisticated methods, but also data, technology, infrastructure, people's ability, and so on and so forth. So a bunch of things happened, and that's how AI now has become a lot more mainstream. Right now, this is all great, but are there some interesting examples of what's happening? Right? Yeah, there's some very serious advances that have happened just in the last 10 years. I'm sure a number of you will know about some of these use cases, but a great way to evaluate if something is mainstream is, going back to the definition, can it perform equivalent or better than humans can? Because our definition of intelligence is defined by our own brains, right? So that's why these numbers make fabulous sense, because if you look at some of the interesting problems where AI is being used, it's about understanding images, speech. Are we able to translate? Are we able to understand when a human is speaking? Are there games where the technology can be better? Two more life-changing use cases, such as a cancer diagnosis. In each of these cases, as you can see, AI's performance is significantly and massively better over a sustained period of time. And that's why it is generally believed now that the age of AI is here to stay, and we are not likely to see another AI winter. A very good example of how advanced things are getting is, I'm sure we all remember the Deep Blue computer beating Gary Kasparov in chess. Then what happened was, chess is a fundamentally finite game. There's a finite number of moves. But Go, on the other hand, to those that have played Go, the Chinese game, there are infinite combinations of moves. So which is why it is considered as one of the toughest things for a machine to break, because what machines are good at, humans are not, and what humans are good at, machines are not. Humans are very good at strategy, emotions, being able to handle extremely uncertain situations, which machines are not. Machines, on the other hand, are very, very good at extreme scale processing, linear structured thinking over a very large frame of reference. All of this, humans are not. But Go therefore was considered as an area where humans would be impossible to beat. But we all know what happened to that. There's this first version called AlphaGo, which beat the world's #1 player, Lee Sedol, by a massive margin. I mean, if you are interested in how he felt about it, you should watch Lee Sedol's YouTube video on what he talks about, an AI beating him. But that was not it. What then happened was DeepMind, which is a company which came up with AlphaGo, created AlphaGo Zero, which did not get trained on anything and simply learned out of all of the games that AlphaGo had played and beat AlphaGo. So this was the first time where artificial intelligence, which did not need prior training of actual games, was able to beat another AI software. And then there was an even better engine that they came up with, which is called AlphaZero. AlphaZero did not learn the game at all. It simply consumed all the images of various positions in the game. It did not learn the game at all. It had no sense of the rules, nothing. Just through extreme scale processing, it understood what this game was all about and beat AlphaGo Zero as well as Stockfish on chess, which is considered the gold standard for chess. It beat Stockfish as well. So now what we can see is that AI has gone from being able to solve a narrow task to a slightly more generalized task to actually transferring the learning from one task to the other. So great advances, right? It looks like AI is all pervasive, but let me just bring AI to the ground in a minute. What we are talking about in all of this, and I promise you, this is the only slightly technical slide, and so I hope it's not too difficult to consume. Everything that we are talking about in the field of AI is in a very, very small space called narrow AI. What narrow AI is about is it is about programming to perform a single task, whether it is about checking weather, it's about playing chess or analyzing new data to write reports and stuff like that. It is also called as weak AI because it can do a task very well if you teach how to do it. So for example, if you teach an algorithm to understand human speech, then it will do a fantastic job of that. But if you ask it to understand pictures, if the same algorithm is asked to understand pictures, it'll miserably fail, right? Because it does not know how to transfer its knowledge from one to another. But if you ask a baby, if you train a baby on one thing, it is able to fundamentally transfer that knowledge and apply that in a completely different context. That's the big difference between AI as it is currently to what humans are capable of, which is consciousness, sentience, and emotion. Now, the next stage, and this is where the experts of AI are working on, is what is called as the field of artificial general intelligence. So this is also referred to as strong AI, where it is about creating machines that exhibit human intelligence. And human intelligence is to be able to perform any intellectual task as good as a human being can, right? So you may remember a movie called Her. What they show in Her is essentially artificial general intelligence. It's great at abstraction, strategizing, and sentience. Now, this is many, many, many decades away. And then the next field is what is called as superintelligence. Now, superintelligence is the ability of an AI to greatly exceed the cognitive performance of humans in pretty much every domain of interest, right? So that's where superintelligence is about. Now, this is what, when Elon Musk talks about AI, he is talking about superintelligence, right? So that's what he thinks will essentially fundamentally lead to the extinction of the human race. And then when all of this is done, there is this concept of singularity. Interstellar, the movie Interstellar is a great example of a very layman's approach to singularity, where it is about humans' realization that humans and machines can coexist to improve each other. And if the subject of interest, I would massively recommend anybody to follow this futurist called Ray Kurzweil, Raykurzweil. So he is a phenomenal futurist, and he thinks about all of these kinds of areas and singularity and transcendence. His sort of books and talks about this topic is phenomenal. But let's just come down to narrow AI. A number of you may have heard about various of these terms, but just to simply break this down, there are essentially two parts to AI as we know it. One is what is called as an area of machine learning, where machines are trained to mimic human tasks, and the second is robotics. Robotics are not necessarily AI. They are machines that are rules programmed to perform a certain task. So automation, what we call as cognitive RPA and robotic process automation, all of this comes into this area. Machine learning, on the other hand, again, splits into three different types. There's something called supervised learning, which a number of us would be used to. Then there is something called unsupervised learning and reinforcement learning. Supervised learning is about machine learning where the algorithm is trained on a lot of data and then is able to do that at hyperscale, right? So predicting the default of consumers on their credit card is a great example of that. You build a regression model, identify who are the people who have defaulted previously, identify those characteristics, and look for those characteristics in other people who have not defaulted. That's the idea of supervised learning. Unsupervised learning, on the other hand, is a more interesting problem where you don't have what is called as prior knowledge. So let's say, I'm trying to understand how many different types of people are there. Now, I may not have a prior understanding of here are the 5 different segments I'm looking for. I'm simply interested in understanding the different types of people that are there based on characteristics that make them close to each other, right? So family is one example of such a segment, right? And there are many such examples where, depending on the problem, you can create a different type of grouping amongst the same people based on what you want to look for. So this is what is called as unsupervised learning. And then there is something called reinforcement learning, which is about a reward punishment approach. So self-driving cars are a great example of reinforcement learning, where the car is built on an algorithm, and the algorithm gets a reward every time it gets it right, and then gets punished every time it gets it wrong. So that's how it constantly improves itself and becomes a much more powerful algorithm. I'll not go further into this slide, but I'm sure people may have questions which we'll take after we go through the other sections. Now, AI is not always great. I'm sure a number of you have followed this. If you haven't, this is Tay. This is the AI that Microsoft created as a bot. And this was their automated bot that they launched on Twitter one fine day. They said, Microsoft has come up with a bot that's going to speak like humans and is going to tweet like humans. And it started tweeting in the morning. It said, the first thing that most Microsoft programs say, hello world. And then, it said good things such as, humans are super cool. Very quickly, we are fantastic at breaking machines down as humans. And what we did was we started interacting with the tweets, and we started sending various types of messages. People started sending various types of messages, and immediately it started learning from how people were sending messages and started responding in the same manner. It started saying rubbish, such as women are inferior, we are going to build a wall and Mexico is going to pay for it, and stuff like that. And all of this is happening in one day, right? All of this is in one day. And very quickly, by the end of the evening, Microsoft realized how poor its understanding of natural language processing is, and said, you know what, this is the end of our experiment. We are done with this. So this was all in one day. They started and finished this experiment on natural language processing as soon as they realized that they are not at all ready. I don't need to explain this much at all. There is with every good thing that happens in the world, everybody wants to make whatever they do AI. So there's a beauty pageant that happened. There was a lot of pressure on young contestants. Beauty pageants often face public scrutiny, and there's alleged unfair practices and so on. To combat some of this bad rap, this agency set up beauty.ai. It set up a contest and used a machine as a judge. And the machine's algorithm was supposed to objectively examine facial symmetry and identify wrinkles, blemishes, and then point out, people or contestants who embodied human beauty. As expected, what happened was about 8,000 people contested. About 40 winners were announced. Only one of them had dark skin. So very quickly, this whole experiment failed. And that led to people like Elon Musk saying, you know what, this is rubbish. AI is, as we understand it, AI is definitely not going to be net positive to humans. In fact, it's going to actually lead to extinction of humans, but more quickly in near real time, it's going to lead to issues such as what Tesla faced with their Model 3, where they promised a lot more than they could deliver because they didn't realize how complex their AI was. And they realized that humans are underrated. So those are some examples of what's happening. It's a whirlwind tour. But what does it mean to us, right? What does a career in AI look like? So this is how, yeah.
Just, I think we are about 20 minutes up. So if we can, look at reducing the thing a bit so that we have more time for interactions.
Absolutely, absolutely. I just have a couple more slides, and I think this may be interesting in terms of how people think about careers. So at Fractal, this is how we think about careers. Everything that we do is at the intersection of what we define as AI, engineering, and design, right? AI is about algorithmic sophistication, engineering is about technological superiority, and design is about building everything with the human in mind, right? So our career tracks therefore have these, sorry about the background. Our career tracks are about some super specialized tracks such as a data scientist, engineer, and designer, and some what we call as dual specialty tracks, an AI engineer, decision scientist, and information architect. Obviously, these are, there are nuances to how each of these work, and I'd happily take, people through what it means and what it means to get into this career, offline. But fundamentally, what do we need to teach and what do we need to learn? It really is about problem solving, right? It's about problem solving, which is understanding what's the big picture that you're trying to solve. There's a series of uniquely human skills, which I'll come to in a minute. How do we learn is important. Acceptance of the fact that there is no one right answer to any problem. Ability to embrace digital data. And finally, AI can go terribly wrong unless the controlling forces, which is our human thinking, has ethics built into it. And that's where the uniquely human skills come into play. Things that AI, at least as we stand today or in the next few years, cannot do well, is about these elements, right? It's about compassion, creativity, empathy, humor, adaptability, originality. And everything that we do in corporate life as well as personal life has elements of this, right? And that's where the world is clearly progressing towards a human-machine augmented approach. And just to illustrate this entire thing in one simple illustration, real-world example, I'm going to stop talking and just share with you a minute and 30 seconds video, and that ends my session.
I'm Saqib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind, and that's where I was introduced to talking computers, and that really opened up a whole new world of opportunities. I love making things which improve people's lives, and one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces, 40-year-old man with a beard looking surprised, 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
years ago, this was science fiction. I never thought it would be something that you could actually do. But artificial intelligence is improving at an ever faster rate. And I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
Thank you very much, folks. Back to you, Arushi and Rajiv.
Thank you so much for the Shankar. I mean, that last video was really inspirational. It was quite cool to see where the technology is advanced to. Let me take a few questions. So everybody, if you can list down a question. I have only one question from Sapan, which is also on line with what I wanted to ask. So Sapan asked, where does deep learning fall on page 10, right? And a bit of an addition. So I wanted to also understand. You said that with the advent of deep learning, you feel that the winters are now over, right? So what in deep learning makes you feel that you won't find another winter?
Yeah, absolutely. So let me just take that question. So look, deep learning is just a subset of machine learning. There's different schools of thought on what constitutes deep learning, but essentially it is about anything to do with the neural net based approach is classified under deep learning. Some of the folks also classify autoencoders under deep learning. What is deep learning, right? It is essentially a specialized form of machine learning where the learning happens at hyperscale. So it requires extensive data, it requires extensive processing power, and all it does is deeply trains the algorithm on something that you want it to be trained on. A simple example is the cats and dogs example, right? So you throw an image and you want the machine to say if it's a cat or a dog. For us, it's a really easy problem. You look at it, you know it. But for machines, it's a very, very, very difficult problem, right? And there's all sorts of fails on a dog being, captured by a machine as a cloud and stuff like that. There's all sorts of examples are there. So for it, it's a very tough problem. That's what deep learning is about, which uses this concept of convolutional neural networks to build multiple layers, neural network layers to take an animal, break it down into its constituent parts, which is the contours of the animal, the fact that it has 2 eyes, 2 ears, and stuff like that, into identifying that it is a cat or a dog. Now, why is that a big deal today? Because in 2011-12, there was this report from McKinsey that came out on the transformative power of big data. That one report, I think, genuinely transformed the world of the world into what power we have in our hands by leveraging the data that we create and the data that we already have. And in parallel to that, there's tremendous advances in overall technological sophistication, right? The ability to process a lot faster, the size of chips reduced, the ability to process a lot more within what we initially used to have as CPUs, then became GPUs, graphical processing units, and now it has become TPUs, which are tensor processing units. So all of this advances across multiple fields. Led many people, including me, to start believing that winters are done for now.
Okay. Does anybody else have questions here in the audience?
Hey, Rajiv, Mala here.
Hi, Mala. Go ahead. Nice to see you.
Nice to see you too. I'd love to know a little bit more from SN about the ROI of AI. I'm not sure if you already spoke about it because I joined about 10 minutes late. So in case you did, if you can kind of just share a little more insights on how you guys calculate or do not calculate the ROI on AI project.
Yeah, Mala, this is this is probably the most difficult question to answer, right?
Which is the reason why I'm asking you.
Yeah, yeah. Look, I think it's a subject I can talk for hours on end. And in fact, I did a podcast on this, and I'll share with you the details post this session. Uh, uh, so look, it's not easy. The reason it's not easy is because one of the earliest things I was saying during this discussion was that the definition of ROI is a moving target, right? As soon as we achieve, it's a moving goalpost. Most organizations, I'm sure you're asking from that standpoint, most organizations are not looking at a finite set of activities to be completed or one goal to be achieved. As soon as we are getting close to a goal, the goalpost is moved. So what we define as ROI becomes very difficult to genuinely construct and measure. So what we do on this front at Fractal is much like most companies I'm sure are doing, is use the approach of test and learn, right? So once you have an idea or a concept that you're working on, what is the testing approach? How are we going to test the likelihood of the size of price, and then how do we then scale that to achieve true ROI? So that's how we look at it. And there's, of course, that's a very simplified answer. There's many nuances around the various levers that are there. And if that's of interest to you, I'll happily talk with you separately and also share with you that podcast.
Yeah, I would like to do that. I mean, because where I'm also kind of, what interests me also is that a lot of companies are investing in projects which has AI in it,
Yeah,
but one kind of doesn't know where they start kind of thinking about, has it been successful, or can it not, has it not been successful, right? Because really speaking, you don't know what the denominator is and the nominator is, or numerator is over here. It's a moving target, and different people within organizations have different vested interests also, because so it's a real world problem that I'm kind of talking about, more than sticking to the specific topic of the technologies as far as AI is concerned.
absolutely, Mala. Couldn't agree with you more. It's a topic of interest for me, so I'll gladly take this conversation offline with you.
Yeah. Okay.
Yeah.
I think the next is from Vishwaraj. He's probably asking about that one slide about, can you talk about career paths in more detail?
Yeah, sure. So look, there's a bunch of ways in which the typical career path of a person wanting to get into the field of AI progresses. Fundamental to all of this is, as I said, problem solving. There is, if you want to be in this field, there is tremendous importance that you need to give to problem solving, and most of us have come from good business schools, so that part of our capability is likely to be quite high. So now, there's three specialized areas and three sort of dual specialty areas, as I would say. One of the most common careers that I've seen people to do is what is called as a decision scientist. So this is a good mix of applying the math, stats, and artificial intelligence learning and orientation that one can get with good problem solving, good ability to construct and structure something better, to design coming together. So this is a place where I see a lot of people progressing towards. You may have heard terms like AI translators. So these translators are essentially roles that tend to be acting as a bridge between core specialty folks that are the data scientists and the machine learning engineers, with folks that are in the business, on the business side, like Mala was pointing out, people that are looking for ROI. So this translator group is a very important group, which actually brings these two together. And again, to quote McKinsey, they released a report around the likely gap that is going to be there in the world of in the corporate world around AI, machine learning, and translation. They estimated that about 200,000 such people will be needed by, I think, 2018-19, and we are well short even today. We are well short. We are, this is an area of deep interest to a number of people because there's so much opportunity in this space. Then there are other specialty areas like the AI engineering, data engineering, and data science, which is really about genuinely getting deep into the modeling approaches. How do you convert a business problem into a very technical problem, and then writing a lot of code around it? So people that are coding enthusiasts, people that are used to writing stuff in Java, Python, R, and these kinds of languages may take to this career very easily, because it is fundamentally about writing up multiple programs. So we've seen a number of cases where people that have done lots of work in the old world technologies have been able to migrate very quickly into these kinds of areas. An area which I think is not getting enough importance, but is soon going to get lots of importance, is in the information architect area. These are people that are able to visualize data. It's one of the toughest things to visualize data and to be able to convert a table or a database or text and whatever else into insightful information that somebody can use. Now that's a very, very, very difficult skill set, contrary to what people may think. So because it's easy to do this one-off, but it's very difficult to do this in a very big way, right? So if you're looking at the scale of a Walmart, a Google, and places like that, how do you do this in such a scaled manner is really about bringing together design skills as well as core data engineering skills together. So that's where we are building our careers at Fractal. Hope that answers, Vishraj.
Vishraj, does that answer your question? Yeah.
Yes.
So the next question is from Gaurav. Can you please talk of AI in vaccine development? If you're aware, has Ray Kurzweil's year of singularity changed post-COVID?
Good question. I don't know if his perspective has changed. I've not recently followed. Actually, thank you for the reminder. I should check. But look, vaccine development, the area of healthcare is one of the most disrupted areas on AI. So if you look at the funding around AI over the last few years, the biggest amount of funding has gone into AI in healthcare for two reasons. One, because it saves lives, of course, it's a big reason. But more importantly, the second reason is because it's one of the most inefficient sectors in the world. I don't know, I'm sure you all agree to that. I'm sure you're all nodding your heads. But it's one of the most inefficient industries across the world. I mean, the US is a joke. The UK is, every day we hear newer and newer stories. And a number of countries in Asia Pacific don't even have access to great healthcare. So this is a place where there is a lot of AI work going on. In fact, one of our recent products that we've built just got 4 FDA approvals in one go. It's the first ever AI program in the entire world to get 4 FDA approvals in one go. So we are doing a lot of work in healthcare, and vaccine development specifically is, there's a lot of work going on. However, it is not an easy problem. Vaccine development is not easy, not because of any other reason, but simply because the regulations around how much explainability needs to be brought in is very high. So the regulatory bar on AI and the explainability that is required is extremely high. So the pace of development from a math standpoint is great, but from a practical ROI standpoint, it is not yet reached that stage. But I think over the next 3 to 5 years, that's a place where we'll see a lot of action.
Gaurav, does that answer your question? Yeah. Great. The next is from Savan. How big a problem is it dealing with privacy as AI keeps evolving?
Yeah, massive problem. Absolutely massive problem. GDPR is a very poor example of a good idea, but it's a massive problem because not because of any other reason, but who decides who owns what data? It's not very clear, right? Who decides that I own my data, or that I don't own my data? how does that decision get made? I'll give you a simple example, right? Let's say I fill the form of a company and I share my data. Now, because I chose to share that, have I made my data, and I make my data available, have I surrendered my right to that data? I don't know. Now, the very fact, I mean, the fact that a company has set up a database and has made investments to capture the data and store that data over a period of time, does that make them owners of that data? We don't know. Let's say they create data out of it. So I've just said that, hey, I'm Shankar. I'm a human being. I'm a man. I'm this age. I'm this profile, and so on. And then they create more data out of it, saying Shankar is in the field of AI. He talks a lot. He presents in sessions and stuff like that. They create a lot of data. Now, who owns that data? Is that data also my data because I provided the original data or not? So this whole field of what is my data, how private is my data is not clear. Unfortunately, I don't have a good answer for you, Savan, on is can we solve for this? Is it a big problem? The answer is an obvious yes. It is a massive problem. A bunch of governmental setups as well as industry bodies are working on making this better and better. So we are part of the IEEE society where we are actually helping write some of these rules, specifically in Europe, to see how we can actually make incremental steps around it.
Vikas has a question. Firstly, I mean, Savan, do you have any follow-up questions to Shankar? Perfect. Vikas has a question on career paths. Can you recommend which course, translator, decision scientist to info scientist, and from which universities one should aim for specifically mid to senior managers?
Yeah, sure. So I'll actually, I'll give you an answer right now, and I'll share with you more details because obviously there's a bunch of courses that you can look at. But a great place to start is either Coursera or Udacity. So both of these, I'm sure you guys are using it. So Coursera, and just simply search for machine learning. There's a bunch of courses. Coursera is great because it actually brings multiple different courses from multiple different universities together. So if you ask me, is there one or two programs that I would recommend? Of course, if you have the time, bandwidth, and to invest into this, of course you should study in an MIT or Stanford because their AI courses are 2-year programs and they're very, very good. There is a New York University MS in data science, which is also fantastic. There's a really good King's and Oxford AI, data science, grad program that's very good. But these are full-time programs. There are a number of part-time programs which do a great job of this, and that's where you start with Coursera. So if you look at Coursera and look at any of the courses which talks about practical applications of AI, machine learning basics, and design thinking with analytics and so on, that'll be a great start. One particular person that I would recommend that you look at is this guy called Andrew Ng. So Andrew Ng is considered a solid expert. He was one of the chief architects behind I think Baidu, if I'm not mistaken. And then of course he worked in Google as well. So he has this program on AI, which is a great start for as a refresher, right? He breaks it down into a very simple level, but also does not simplify it, right? He keeps the concepts as you should learn, but he keeps the explanation very lucid, and it's a great start. And then from that point onward, it's about which area you're interested in.
Quick question, if that's
yeah.
Just on this slide, Shankar, you spoke about sort of the super specialized career tracks which are on the edges, and then the dual ones which are, on the corners. But there's also the circle in the center around problem solving. I'm wondering who does that, and if there's a career track around that.
Absolutely, absolutely. I mean, I think a number of us in this room may be somewhere there. I think this is look. We we thought about, at Fractal, we thought about what do we want to be as a company. Initially, we called ourselves an analytics company. Then we said, should we call ourselves a consulting firm, because what we do is problem solve for large corporations. And then we realized that general problem solving without having the depth in any of these areas will not make us differentiated. And general problem solving is starting to become very focused on certain segments of corporations. But if you want to run scaled programs, then problem solving with an orientation into any of these three sort of specialized areas becomes a serious differentiator. So that's how we looked at careers within Fractal. So the way we are thinking about it is, yes, problem solving is hygiene. If you don't have that, I mean, learning AI without problem solving is not going to get you anywhere other than academia, right? Or learning design without problem solving is not going to be practical for a company like ours. So that's where problem solving becomes extremely hygiene, but problem solving plus a T orientation or building depth in one of the areas becomes a highly differentiated proposition.
Thanks.
Vikas, do you have any follow-up on your question? I had a small follow-up on that, Shankar, on that one part, right? And I know that we're slightly going over time. On the thing about so I think many of us, at least few of us I know in this room, have like done a few courses in AI and trying to get in, right? What is it? I mean, and many of us here are like mid to senior career professionals, right? How do you make that position? How do you make that jump from that Coursera course to opportunity? What are the kind of titles, etc., that we should be keeping our eye out for?
Yeah. It's a really good question, Rajiv. Look, a number of companies have teams such as insight teams, analytics teams, insight teams, and so on. So any sort of designation that you look at in various opportunities which has an insights layer into it, that is a great place to. You should know that's a great place to enter, because insights as an area is quite wide, but it basically what it does is, insights, if you have to define insights, it's taking a hazy problem, converting it into a structured problem, converting that into an analytical problem, solving for it, converting that into an insight, and making that available. So that's really the continuum of insights. So here is a great area to enter through your strengths, which is problem solving or consulting or whatever else that you do. And then from that point onwards, Coursera courses basically add that analytical edge to you, which then makes you a slightly more deliberate insights professional. So that's how I see a career path. Then of course there are these other types of careers. If you see anything with a data on it, you should be very clear that that's an analytical area, right? Whether it's a data engineer, data scientist, these are terms that you will see everywhere right now. Every company, from the UK post office through to Google and Microsoft, you see these roles everywhere. So those are great places to enter as well.
Great. Great, thanks. Vishwaraj, do you have a recommendation after Andrew NG's Coursera course? So
yeah. The Udacity has what are called as nano degrees. I don't know why I forgot about it. So nano degrees are great. Nano degrees are 3 to 5 months type courses. And they have data science nano degree, they have machine learning nano degree, data engineering nano degree, bunch of nano degrees. So these are essentially, as the name says, it's a degree, but it's just a crunched form of it. It typically involves about 5 to 8 hours of work every week for a period of about 4 to 6 months. So that's the kind of commitment that you need to have. But they are fantastic because you get a very, very deep perspective, and they also help transition into careers of this nature that you see on the slide.
Great. I think now we are 4 minutes over, so I think it's a good time to end. If there is no other questions, thank you so much, SN, for your time. It was I think it was great, from a couple of perspectives. One is to understand the different concepts, but also to understand, I think, what are the career paths that you can take, right? I think that's the best thing that you can take forward from here. We will in the future, what we're planning to do is we will be having these sessions mostly on a quarterly basis. We have already got interest from few people who would like to speak, so probably we will club a few on certain much more deeper topics. This is just to cover the basics so that everybody is on at a similar page, but then we will bring in people together on like specific concepts, and then take the conversation forward. So if you're interested to talk on these on any of the subjects, let us know, and then we will just do that clubbing and take it forward from there. Yeah. Thank you so much again for your time, and see you soon.
Fabulous. Thanks, everybody. And Arushi and Rajiv, thanks for organizing this. Keep up the good work.
Thanks. This is a fantastic job, Rajiv and Arushi.
Thank you so much, Mara.
Okay.
Thanks a lot,
Yeah.
Rajiv,
Thanks, Sankar.
Arushi. Thank you.
Bye.
Thank you, everyone. Bye.